Okay, on to chapter 2. So here's 2.1. And what this is asking is to find this Sx and Sy operator. Um, and so what this is really saying is if you apply this Sx operator to the, let's just say up ket for in the x direction, what you get out is positive h bar over 2. And then you get the up x ket back again. So basically, this operator is basically pulling out a h bar over 2. If we did it with the down and you applied it to the down ket, then you get negative h bar over 2, and then the down uh, ket back again. So it's saying just to find what is this operator that would give you this h bar over 2 out of this. Okay, so we'll start with x, and remember that, and so one thing that was kind of confusing with the wording of this question that first time I went through this book, I was a little bit confused by is what they meant by in the z basis. All that means is just the standard, what we've been doing, so that like the up in the x is going to be 1 over root 2 up plus 1 over root 2 down, like that. This is coming from the z direction. So if we kind of sorted out all of our spins from the z, we have 50% up, 50% down. Unless we take all of it from the z, so we know that it's up in the z, then what do we get from x? And that's going to be that's 1 over root 2, 1 over root 2. So it's coming from the z direction. That's what it means by in the z basis. So we can sort of ignore that, just knowing that when we have the subscript x here, then that's what we mean here. So we're also going to be doing this in matrix notation. So this here is going to be our up is going to be 1 over root 2, 1, 1. Right? 1 over root 2 for up, 1 over root 2 for down. The bra is going to be the same. If we want to write that out, we can. So we'll have it here, 1 over root 2, 1, 1. Our minus is going to be 1 over root 2, and then we're going to have 1 and then negative 1, right? Because if we were to write this out, and this all is going to be in the x, if we were to write this out, then it would be 1 over root 2 up minus 1 over root 2 down. So that's just in matrix notation there. And then the bra of that would be the same. Don't really need to keep all of these here because I'm going to need more space, but 1, negative 1. All right, so that's for our x. So we'll stick with the x for right now. And so again, so we have this operator here. We don't know what this operator is. So for right now, we'll have a placeholder here. We'll call it, all these operators are going to be 2 by 2 matrices. So we'll do A, B, C, and D, just as our placeholder matrix. And if you want, I don't think the book does it this way, but I saw a video doing it this way and I liked it, having some constant that you can pull out of this matrix. You can either bake in the numbers there. We're going to have some h bar over 2s. You can either have that in the matrix or you can pull that out of the matrix, whatever you prefer. I like pulling it out. So that is going to, when we apply the matrix to our, we'll start with up. So we have 1 over root 2, 1, 1. That's going to be our up state for x. That's going to equal h bar over 2, and then we're going to get this back again. So 1 over root 2, 1, 1. All right, so now all we need to do is figure out what our A, B, C, and D are. So if we multiply this across, so first we can pull out this k and the 1 over root 2. And then we're going to have, we flip this to the side, we're going to have A plus B. And then bring it down, we're going to have C plus D. If you don't know that, it says 1 times A is A, plus 1 times B is B, and 1 times C is C, plus 1 times D is D. All right, so then that's going to equal h bar over 2, 1 over root 2, 1, 1. Okay, so now we can kind of see some similarities here. So we have this, we have a something here, we have a 1 over root 2, and then we have a matrix. So we know that our k, we know what our k is now. Our k is h bar over 2. So we'll write that right here. So k equals h bar over 2. Our a plus b is going to equal 1. And our c plus d is equal to 1. All right. So we can't really solve that yet. We need some more information. So we'll go back here and we'll continue on. So we know that for the down bra, we have it here. Yep. Down bra, we have 1 over root 2, 1 minus 1. And what we're going to get out of that, if we apply it to the down ket, then we're going to get negative h bar over 2 and the down ket. So we're going to get negative h bar over 2 and the down ket, which is that. Okay. So what we can do, well, we won't do that right now. Okay, so first we'll do the same thing. We'll do k 1 over root 2. 1 times a is a. Negative 1 times b is negative b. 1 times c is c. Negative 1 times d is negative d. And that equals negative h bar over 2, 1 over root 2, 1, negative 1. Okay, so again, we could see that we have a 1 over root 2, we have a something, so our k is negative h bar over 2, but wait, we already said that k is positive h bar over 2. So yeah, it can't be two different things, so we need to pick one. We can choose to change it to negative h bar over 2, but we need to go and then change our first result. So we'll go ahead and keep that. We will go ahead and make this positive and just basically just multiply everything by negative 1 here. So instead of pulling out a negative h bar over 2, which is what we basically have done in our matrix, instead of pulling out a negative h bar over 2, we pulled out a positive h bar over 2, which means that signs just flip. Because this matrix would have looked, if we wrote it out with the h bars inside, it would have looked like this. It would have looked like h bar over 2 minus h bar over 2. No, sorry, it would have looked like this. Would have looked like that. So we could have pulled out a negative h bar over 2, and then that would have become 1 and negative 1, which is what this is right here. But instead of pulling out a negative h bar over 2, we're going to go ahead and pull out a positive h bar over 2, which means it's going to be a little bit different than that, but that's okay. So we do know that a minus b is going to equal negative 1, and c minus d is going to equal positive 1. Okay, so now we can solve this. So if we were to combine these two, so we have a plus b equals 1, and a minus b equals negative 1. If we were to add these two together, we get 2a, b's cancel out, equals 0, so a equals 0. So we know that a is equal to 0. And if a is equal to 0, then b has to equal 1. We do the same thing with c. So we combine these. So then our d's will cancel out. We'll have 2c equals 2. We have a positive 1, a positive 1. So 2c equals 2, or c equals 1. And if c equals 1, then d has to equal 0. All right, so then now we have all of our letters here, and now we have our k is h bar over 2. Remember, we use this form for our operator here. So h bar over 2 is our k, and then 0, 1, 1, 0. And that's going to be our sx operator. So sx can be portrayed by that. A little equal sign with a dot means this is represented by this. Okay, so then that's our sx operator. I will write that just so you have that on the screen. Sx is equal to h bar over 2, 0, 1, 1, 0. Okay? So now we'll do the sy. So we will get rid of everything here. And we know that our y direction, so the up, is equal to 1 over root 2 up plus plus I, 1 over root 2 down. And the bra, well, first let's just do matrix notation. We're going to be doing all this in matrix notation here. So that is 1 over root 2, and we have 1 and I there. If we take the bra of that, that's going to be 1 over root 2, 1 negative I. And then the minus in y is 1 over root 2 up minus I, 1 over root 2 down. And then, so the bra, remember, is going to be in, it's going to be a row matrix, not a column matrix. So it's going to look like that. Okay, I'll move that over a little bit. 1 and negative I. Okay, so I'll write them all out. It can't hurt, just extra practice. In matrix form is going to be 1 over root 2, and then inside is going to be 1, and then negative I. The bra form of that is going to be in row vector form, and 1, and then we have to complex conjugate that to make it I. Okay, so we have all those written out there. So now we're going to go with this one. We're actually done with this over here, so I'll erase it so I don't get confused. All right, so our SY, again, we'll put it in the form of K, A, B, C, and D. And when we apply that to our, these should be Y's here. When we apply that to our up Y, so our up Y, I don't know why I wrote all the bras here. I just realized we don't need them. I did that for the X's too. I didn't realize we never use them. But anyways, it was good practice. So here we have 1 over root 2, 1, and I, and that's for our up. And that's going to equal positive h bar over 2, and then our positive y again, so 1 and I. All right, so what we get here is we pull out our k and 1 over root 2. 1 times a is a. I times b is ib plus ib. 1 times c is c, plus I times d is id. Okay, and then again, that equals h bar over 2, 1, and I. So we can see here that a plus ib is equal to 1. C plus id is equal to I. All right, and now we'll do the down. So it'll be 1 and negative I. And this is going to be negative h bar over 2 and negative I. Okay. And from before, we know that we made our k, I didn't write that down, but we have our k is equal to positive h bar over 2 already. So because we're wanting our k to be positive h bar over 2, let's go ahead and just flip the signs here. Make this positive I and negative 1. All right, so pull out our k and our 1 over root 2. This should have had a 1 over root 2 this whole time. Left that out, but okay, so pull that out, and then 1 times a is a. Negative I times b is negative ib. 1 times c is c. Negative I times d is negative id. And then that's going to equal h bar over 2, 1 over root 2, negative 1, and I, because we already did the pulling up the sign thing. So now we know that a minus ib is equal to negative 1. C minus id is equal to I. And then we are good. We can start to solve these. So if we combine these two, that cancels out our IB terms. And then we have 1 plus negative 1 is 0. So our A is going to be 0. If A is 0, then B has to be what? So if A is 0, then IB is equal to 1. And if IB is equal to 1, what we can do is we can multiply both sides by negative I. So times negative I times and times negative I. So negative I times I is just 1, so that becomes B equals negative I. So B is equal to negative I. All right, so C, combine these two, so that cancels out our ID terms, and then that gives us 2C is equal to 2I, where C is equal to I. And then if C is equal to I, then D, or ID, has to be 0, which means D is 0. So D equals 0. All right, which means our K is H bar over 2, and A is 0, B is negative I, C is I, and D is 0. And that is going to be our SY operator. So our SY operator is shown by H bar over 2, 0, negative I, and 0. All right, hope that helps. And be right back for 2.2.